Okay, so as I said, I'm Dr. Rachael Livermore. I am an astronomer here at UT here in Austin, and we're going to delve into the science of Star Trek 2009. So there is an awful lot in this movie, and I cannot possibly cover it in the time that I'm allowed. So I'm just going to pick out some of the highlights, and I'm going to start with that very first scene. So this is the USS Kelvin, right at the beginning of this movie. And this was the very first shot of the movie. Now, there's so much cool stuff going on in this scene. Like, first of all, you hear the beeps. If you're an original series fan, you're going, yeah. But the thing that I think is really cool is that when we zoom into the ship, it's upside down. And this is just a really cool little detail, because there is no up in space. And yet, somehow in science fiction, ships always meet each other facing the same way up. And we see that again when we come across the Narada drilling into Vulcan. It's just hanging upside down off the planet, because why wouldn't it be? Why would we happen to arrive at Vulcan the same way up as the Narada? So that's a really cool little thing that I don't think enough science fiction movies do. And we are going to come back to this scene with the Narada a little bit later, because it's actually quite interesting. So there's one thing that every science fiction action movie ever gets completely wrong, and that is space battles. So space battles are always wrong in every movie. There's so much going on here. You've got things exploding. Everyone knows fire needs oxygen. There's no oxygen in space. You get a little bit of fire because there's oxygen in the ship, but that would expand and dissipate pretty quickly. So these massive fireballs, completely wrong. There's also, I muted it because I wanted to talk over it, but there's sound going on. You don't get sound in space. You need matter to transmit the sound, so there's no sound in a vacuum. And although there is air inside the ship that's being blown out again, that would dissipate very quickly, so you wouldn't be able to hear anything. So everything about this is wrong. And honestly, I could talk for an entire talk on why this is wrong. And if you're interested in that, you can go to the Astronomy on Tap YouTube channel, and our friend Dr. Chris Linder did actually give a talk on why all explosions in space in movies are wrong. So I recommend that. But there was one thing in this scene that was really, really cool. And the excuse you always get when you complain about there being sound in space in movies is, well, you need it for drama, because if things are exploding and it's quiet, well, that's not exciting, is it? And I beg to differ because of this scene. So you've got screaming, screaming, screaming inside the ship, and then as she gets blown outside the ship, silence. I don't know about you, but I think that's pretty dramatic. And I wish more movies did that, because it's really cool and eerie and really tells you you're in space and this is scary. So moving quickly on, I'm going to skip the really annoying scene where the young Kirk dives over a cliff and defies all laws of physics, because I don't have time, but suffice to say I find that annoying. So let's go straight to Vulcan. I could have a long rant that I was going to, but I had to cut out for time, about our first view of Vulcan and how inconsistent it is with the original series, but whatever. I'll have a little bit of a rant about that later. So first of all, we see Vulcan's schooling. And this is really cool because we don't get much of a view of Spock as a kid in the original series. So here we have young Spock, and he's taking some kind of exam. And so what questions is he being asked in this exam? The first one you hear is the volume of a sphere. He then does some general mathematics. Some of it is unintelligible, some is just basic arithmetic, others don't appear to make any sense. You can't really have a dimension of a logarithm, but whatever. This gets really diverse. He goes into economics. You hear him mention non-exclusibility and what was the other? Non-rivalry. That refers to public goods in economics. You then have the volume of a sphere again. Out of nowhere he says 4/3 pi times the radius cubed again. Why not? And then it's either ethics or possibly vocabulary. What you hear him say is when an act is morally praiseworthy but not morally obligatory. So the question is, when is an act supererogatory? Whether that's an ethics or a vocabulary question, who knows? Either way, this is pretty random. And so I'm going to use this as an example next time a student complains about having an exam that covers too much. So here's my rant about Vulcan and being inconsistent with the original series. So we meet Spock Prime. This is a really sad scene, so I feel really mean ranting about it. But you see Spock, and he's watching the destruction of Vulcan. Now look at how big Vulcan is in the sky. That is not a distant planet. That is, you are in orbit around that planet, or vice versa. You are very, very close. That is bigger than the full moon in the sky. So where the hell is Delta Vega? So there is a Delta Vega in the original series. It's actually in the second pilot episode where no man has gone before, and it looks like this. And I can tell you right away, this is not the Delta Vega in this movie, because this Delta Vega is way out at the edge of the galaxy. It's definitely not that close to Vulcan. So we can do away with that. So it has to be Vulcan's moon, right? Except...
Vulcan has no moon, Miss Uhura.
So this is from the episode The Man Trap, and you might say, well, Spock was just trying to shut down Uhura's really awkward attempt at flirting, except that exact line is repeated in the animated series episode, animated series, Yesteryear, which, if you've never seen the animated series, if you just want to watch one episode, Yesteryear is pretty good. It's the only time we actually see Spock as a kid, and you see him get bullied by the other Vulcans, who are very mean. But interesting thing about Yesteryear, it repeats this line, Vulcan has no moon, and yet this is our view of Shikar, the city on Vulcan, and what is that gigantic thing? So the story goes that when they saw the artwork, Gene Roddenberry and DC Fontana actually scrawled on this, Vulcan has no moon. The artists apparently didn't see the script, and the message never got back to them, so it stayed. So then they had to retcon it, and they decided that Vulcan doesn't have a moon, it has a sister planet. However, that sister planet is not called Delta Vega. You also notice, if you watch the motion picture, the first Star Trek movie, don't watch the motion picture, but if you do, you see this view of Vulcan, and some gigantic things hovering there in the sky. However, if you watch the director's edition, again, don't, but if you do, you'll see that these got taken out and replaced with our normal view of Vulcan with the red sky. So where Delta Vega is and whether or not Vulcan has a moon is an extremely controversial subject among Trekkies. So let's move on into space and talk about life in space. And we're going to start with someone who, in my opinion, really should have chosen a different career.
Pander to me, kid. One tiny crack in the hull and our blood boils in 13 seconds. Solar flare by crop up cookies in our seats. And wait till you're sitting pretty with a case of Andorian shingles. See if you're still so relaxed when your eyeballs are bleeding. Space is disease and danger wrapped in darkness and silence.
Well, I hate to break this to you, but Starfleet operates in space.
So, in my opinion, Bones is the best character in the reboot. However, I'm really not convinced he earned his medical degree. So he talks about one crack in the hull and your blood boils in 13 seconds. Now, I'm not that kind of doctor, but no. Liquids do boil at lower temperatures, at lower pressures. That's true. And so blood, if you had it in an open container, would boil in a vacuum. However, your blood is hopefully not in an open container. It's contained within your circulatory system. If it's boiling within 13 seconds, you've got much bigger problems than the crack in your ship's hull. He then talks about solar flares. So what he's talking about, the sun has this ongoing activity, and it can undergo these coronal mass ejections where you have particles flung out into space. And they can be a problem. They can knock out satellites, they can do some damage. However, they move relatively slowly compared to light. And even today, we have ships monitoring the activity of the sun. That's how spaceweather.com works and can tell you whether there's going to be an aurora. So you're not going to be suddenly surprised by a solar flare. Not only that, but your real problem if you're in space is not solar flares, it's cosmic rays. These are very high energy particles that can actually hurt you. And solar flares actually deflect cosmic rays. So if anything, it's safer to be in space during a solar flare. So that's a very, very odd statement. He then talks about Andorian shingles. Fine, I'll give him that one. So space is disease and danger wrapped in darkness and silence. Absolutely true statement, just not for the reasons that he said. So I think his career choice is questionable for two reasons. He doesn't seem to know much about medicine, at least in this scene, and also he clearly doesn't like space. So I would trade him his job, frankly. So the other thing that Star Trek, and I think every movie ever set in space, gets wrong is space is really, really big. If you think you understand how big space is, you don't. It's bigger than that. So they get around this in Star Trek by having warp drive. So here's the Enterprise at warp. This is a made-up thing that just means they can travel faster than light, which is very handy when you need to go long distances. However, even warp drive has rules. And the rules in the original series were that the warp factor, they quote, is you cube that, multiply it by the speed of light. That's how fast you're going. So if you're going warp 10, because that's math I can do in my head, 10 cubed is 1,000, you're going 1,000 times the speed of light. So that's pretty fast. However, space is really, really big. So if you're trying to go to Vulcan, which is what they're doing at the beginning of this movie, even going at warp 7, it's going to take you 17 days to get to Vulcan. And yet somehow in this movie it appears to take about 5 minutes. And I have tried so hard to fit in a time jump in there to make this make any sense, and I can't. So, I mean, this was true in the original series as well. Warp takes as long as the plot needs it to take. And even within this one movie, it's not consistent, because then later in the movie, they have time to dilly-dally, try and meet up with the fleet in the Laurentian system, maroon Kirk, have Kirk come back, change his mind, go back to Earth. And in all that time, Nero has only just started drilling into Earth. So I have no idea how warp drive works in this movie. So I showed you this scene earlier. This is the Narada hanging upside down off Vulcan. And a lot of people would assume that the Narada is in orbit at this point. And I can tell you just from this one clip that the Narada is not in orbit around Vulcan. And this is why. Two reasons. One, I'm a nerd, and I know that the place he's drilling into is not on the equator. And to remain in orbit over one spot on a planet, you have to be over the equator. That's the only way that works. So, but that's a really nerdy reason. The other reason is that a geosynchronous orbit, that's an orbit that keeps you over the same place on a planet, is really, really, really high up. And the Narada here is clearly only just outside the planet's atmosphere. So the Narada is not in orbit. It's just hovering above the planet, keeping position using thrusters or whatever. And it turns out this is really important because of the scene with the space jump. When this movie came out, a lot of nerds were really angry about the space jump because you can't just jump like that if you're in orbit. If you're in orbit, especially a geosynchronous orbit, you're traveling at tens of thousands of miles an hour. So to go from traveling tens of thousands of miles an hour around a planet to suddenly falling, you're having to change your velocity by tens of thousands of miles an hour. And that's not an easy thing to do. However, I'm insisting this is okay because they are clearly not in orbit. So let's watch the space jump scene. This is really cool. So I'm sure you can guess why I love this scene, because they're currently in space and it's silent. You can hear breathing from inside the spacesuit, and that's it. And then there's a bit of beeping when we're clearly going back to the Enterprise bridge. That's there. And then they're about to enter the atmosphere.
The team is entering the atmosphere, sir. 20,000 meters.
And as they enter the atmosphere, listen to the noise. So at that point, they're falling very, very, very fast. They're going through atmosphere. Atmosphere has stuff in it. It creates friction. Friction creates heat. So they've got noise because they're in an atmosphere. They have heat. You can see they're very uncomfortable. Their space jumpsuits, which are a new made-up thing, are presumably designed to handle that. So this scene is actually really, really cool, and I don't understand why so many people hate it. I mean, I'm not saying I would advise jumping from a spaceship, but as physics in Star Trek movies goes, I think it's actually pretty good. However, it then all goes horribly wrong when Kirk and Sulu are falling without a parachute. And of course, I had to include Anton Yelchin in that clip. So Kirk and Sulu, are falling towards the surface of Vulcan very, very, very fast. They fell from very high up. So if they had been allowed to fall and impact the surface of Vulcan, they would be splattery messes on the ground. Now, it's well established that when you transport someone, they maintain their original momentum. So it doesn't really matter whether what they're hitting is the surface of Vulcan or the transporter pad. They should be splattery messes on the ground. So I'm really sorry to Anton Yelchin, he tried really hard, but they should be dead right now. So I'm now going to get on to the main focus of the science in this movie, science. And I had the joy just now of watching this movie sat next to someone who works on supernovae. And so this was fun. Now, the main driver for the action of this movie is the idea that this supernova is going to destroy not only Romulus, but it threatens to destroy the galaxy. Now, that is a pretty amazing supernova. So to catch people up who aren't familiar with the term, supernova is the name of an exploding star. A very large star, when it reaches the end of its life, it stops burning hydrogen, and the hydrogen burning is creating the energy that keeps the star up. When that stops, it starts to collapse under its own gravity, but at some point it hits the core and rebounds in a gigantic explosion. And these explosions really are gigantic. The image on screen right now is the Crab Nebula. This is a supernova that went off, 1,000 years ago, and still has this huge remnant visible in the sky. So this is a huge amount of energy. However, as I said before, space is really, really big. So a supernova is not going to destroy a galaxy. A supernova will destroy any planets that were orbiting the star itself that went supernova. And within about 50 light years, you're probably going to notice some effects. But you're not going to destroy a planet, even in the next solar system over. So it seems really odd that they chose a supernova to do this. Doesn't make a lot of sense, especially when there are things that could do that much damage. These are gamma ray bursts. The thing about gamma ray bursts, you can see these beams that are shooting out. This is an artist's conception. We don't have pictures quite this pretty. And those beams, although they're in a very small area, are extremely high energy and could totally wipe out a planet further away than their own solar system. But that is not what they used in this movie. This is what any scientist would have advised they do, but they did not. And if we watch Romulus being destroyed...
The supernova destroyed Romulus.
So that's obviously a very bad day for Romulus. But the amount of energy there and the way it got destroyed tells you that was Romulus's star that just exploded. This was not a nearby star, this was their sun. So it's hard to see how turning their sun into a black hole is going to help the situation. First of all, if this is a really, really big star, which it has to be if it's going to threaten to destroy the galaxy, then there is already a black hole at the center. The core at the center of this star will collapse and create a black hole. So there's already one there. So I'm not sure why you need to make another one. And also, being in orbit around a black hole would kind of suck. Black holes are black. They don't give out light. They don't give out heat. So you're going to freeze to death very, very quickly. So really, as soon as they realized the star was going to go supernova, they should have evacuated the whole planet. I really don't see how this is Spock's fault, but not that I want to criticize Nero's 25-year vengeance plan, but it doesn't seem very well advised. So let's talk about black holes. And to talk about black holes, we need to talk about gravity. So general relativity is just over 100 years old. What general relativity tells us is that mass curves space. And this is what gravity is. Gravity is the curvature of space. So what we have here is we're pretending that space is two-dimensional because it makes it easy to picture. And the big yellow disk there is the sun. So the sun is causing curvature in space. The Earth is the little green blob, and that's trying to move in a straight line, but space is curved, so it's going around in a circle in orbit around the sun. Now, what would happen if we took all of the mass that's in the sun and squished it into a smaller volume? It would do this. It would create a deeper dip in space, but the curvature at the position where Earth is would stay exactly the same as it was before. So we can squish that mass down even further into a neutron star. So this is the densest that matter can be. All the spaces between atoms are all squished up close together. This is extremely dense matter, but it's still the same amount of mass as the sun. So at the position of the Earth, nothing changes. The Earth is still quite happily going in orbit around this extremely dense star. So if you take this matter and squish it even further than that, you create essentially a hole in space-time, a singularity, and this is what a black hole is. So a black hole has such a strong gravitational pull that you need to be going faster than light to escape from it. Nothing can go faster than light, with some exceptions we'll come to. So therefore they're black, because light isn't getting out. And yet still, they are just a thing with mass, and they act the same as any other spherical mass. So if you're sitting on the Earth at the same distance away from the center that you were before, everything's the same. You're going to carry on going around in orbit, except it's now very dark and very cold. So the takeaway from this is black holes don't suck. You can quite happily be in orbit around a black hole. I just want to go on a quick digression because this is really cool. A lot of people say to me when I talk about black holes, yeah, but they're just theory, right? We don't know that they're real. Well, the thing is, we do. And so this is a really cool project that's been going on for many years. And these are the positions of stars that have actually been measured in the center of our galaxy over a period of about 20 years. And you can see that they're all orbiting something in the middle. That something has been very helpfully marked for us by a white star shape. That star shape is not real. There's nothing there. It's completely empty, and yet there is clearly something there that the stars are orbiting. And because we understand orbital mechanics, we can work out what the mass of that thing is. And so we know there's a supermassive black hole right there in the center of our galaxy, which is really cool. According to this movie, there's also a black hole somewhere very close to Earth now, which is a problem. If you don't know where it is, you don't want to run across that. So one thing you notice about this video is the stars don't care that they're orbiting a black hole. They're just happily going around in orbit around it. And we too are also orbiting that same black hole while we're orbiting our sun at the same time. So I find it very weird that the way we know that Vulcan is being turned into a black hole is that Chekhov reads gravitational sensors off the scale. So what gravitational sensors are measuring is mass. So what he's saying is the mass of Vulcan is changing. This is not the same as just taking the existing mass of Vulcan and compressing it down to make a black hole. This means that what red matter is actually doing is adding to the mass of the planet, somehow. I'm not going to try and guess how. Fortunately, our heroes are able to escape from the black hole they create when they crash all of the red matter into the Narada. One thing I find very odd is that as the Narada is being consumed by this black hole that is actually in its own ship, the Enterprise fires on it. It seems like overkill at this point. You really should just be focusing on running away because this black hole is growing. But whatever, I know you wanted to get the last word, so whatever. So a couple things about this black hole. First of all, a weird thing about relativity is that if you're falling into a black hole, someone else watching from outside will never see you cross the event horizon. You will forever look as though you're about to fall into the black hole. From your point of view, as you're falling in, everything's normal, but someone watching you from outside, you will appear to be falling in forever. So it's a shame they didn't do that. I guess it would have taken too much explaining for people who don't know general relativity. But I think it would make this Nero forever falling into a black hole would be a cool tourist destination for angry Vulcans. I would go watch, wave, take a selfie. So another thing we see is that the Enterprise is trying to escape from this black hole, and Kirk says something like, "Why aren't we at warp?" And the response is, "We are." Because as I said, to escape from a black hole, you have to be going faster than light, and the Enterprise is one of those things that can magically go faster than light. So they actually can escape from a black hole by using their warp engines to go faster than light and get away. it seems like if they're needing to go faster than light, they're very, very close to this black hole, and so the tidal forces should be ripping them to shreds. And you do kind of see the cracks appear in the ceiling, which I'm assuming is the tidal forces ripping the ship apart. But maybe not as strongly as it should be, but you know, we don't want all our friends to die, so that's fine. So the thing that they do to finally escape from this black hole is they eject the warp core, and somehow that explosion pushes them away. Now this is a really bad idea, because first of all, they need that warp core, because without that they're not getting home. Second of all, for an explosion blast to push you away, there has to be some kind of matter transference that's pushing you. There isn't, they're in space, they're in a vacuum. So the thing there's all this energy and there's light, that's probably not really going to generate as much force as their warp core would have done in terms of pushing them away from this black hole. It seems like a really bad idea, but it gives them this big bang that they get to escape from, so fine, I'll give them that. The last thing I wanted to talk about is Saturn. This is, in my opinion, the coolest scene in the movie, and it came about because of this lady, Dr. Carolyn Porco. She gave a TED talk, that's what this picture is from, while this movie was in production. J.J. Abrams saw it and contacted her. She was the lead of the imaging team on Cassini, which is this spacecraft that's still in orbit around Saturn. And the question was put to her, how do we get the Enterprise into the solar system but hide it from Nero? And so she suggested, well, you could hide in the atmosphere of Titan. And so that's what they did. And that's why we have this awesome scene of the Enterprise rising out of the atmosphere of Titan with the backdrop of Saturn's rings, which is a really, really cool scene, except obviously they get a lot of stuff wrong. So this bit here where you can see Saturn's rings, this is a problem because Titan is in the same plane as the rings. So the rings should just be a line across the sky. But you know, Saturn's really pretty, the rings are really cool, so I can understand why they wanted it to look like this. It would be a waste of rings not to be able to see them, so fine. Another issue is when the ship rises out of Titan's atmosphere, it seems like Titan's atmosphere just has this surface that the ship can rise from. That's not how atmospheres work. They should gradually dissipate into nothing, so that's not quite right. But of course they wanted the scene of the Enterprise rising out of something like a submarine movie, so fine, I understand why they did it, but it's wrong. The most egregious mistake they make is they talk about the reason they're going to hide behind Titan is that the Saturn's rings produce a magnetic field that will mask them. Saturn's rings do not produce a magnetic field. Even Saturn only produces a very weak magnetic field, not as strong as, say, Jupiter. So that line makes absolutely no sense and really does not motivate this cool scene. Now, to be fair, none of that stuff they got wrong came from Carolyn Porco. This is a case where they brought in a science advisor, they had nice intentions, and then they ignored almost everything that she said. So she did get a lot of grief from the scientific community when this movie came out, which is a shame. I assume people were jealous. I was jealous, so that's fine. Now that's all I have time for tonight. If you are interested in picking fun at Star Trek, I do have many more rants, which come from a place of love. Please don't flame me. I get a lot of hate mail for this. But I have a blog, Snarky Astronomer, on Tumblr. I'm currently rewatching the original series and snarking about the science. If you like hearing professional astronomers talk about science, come to Astronomy on Tap. The next event is next Tuesday, a week from today, October 18th. It's at the North Door, just east of I-35 on 5th Street. It's completely free, and there are talks this month on some things. Black holes, there you go, you know all about black holes now. There'll be a lot more detail next week. Measuring dark energy with het decks, and getting in touch with aliens. So this is an event that takes place every month over at the North Door. If you want more information, there are flyers on your way out. So with that, I want to say thank you very much to the Alamo Drafthouse for hosting us tonight, to Odell Brewing for sponsoring us, to Brian for recording this. This talk will be up on YouTube for those who couldn't make it. And of course, thank you very much to all of you for coming out and staying. Thank you.